Discovery friends, it's Miss Barb and we are doing science with Port Discovery at home today. Today we're going to be doing some science experiments, some chemical reactions in bottles, bottle science. So we're going to start with a simple experiment that you can do at home. We have a couple of instruments here. We have a couple of different materials and ingredients that we're going to be using. So let's go ahead and check them off. The first thing that you're going to need is you're going to need a bottle. I have two right here, an old Gatorade bottle and another juice bottle. You're going to need some measuring tools. We have a tablespoon right here, 1 tablespoon. I have a 1/4 measuring cup and a little dish measuring portion cup that also will measure 1/4 right there. And then I have a funnel, a pencil just in case I need help getting my ingredient down into the funnel, and I have a balloon, a rubber glove, and the items that we'll be mixing together, the ingredients we'll be mixing together today is baking soda and vinegar. So what we're going to do today is in the bottle, we're going to mix the vinegar and the baking soda together, and we're going to see what happens. What do you think is going to happen here? So first step, let's go ahead and get the bottle. The first bottle, I'm going to measure exactly the measurements that are going to be on our matching blog for you guys on our website. So I'm going to do exact measurements. The first thing that we're going to do is we're going to measure out our vinegar. We're going to measure out 1/4 cup. Same thing, you can use a liquid measuring cup. You can use a little, this is a dry measuring cup, but it works too, or this little cup. I'm going to use this one. I'm going to do it over this just in case I spill a little bit. It will catch. So we're going to do 1/4 cup liquid vinegar. And we're going to pour that in. Here we go. Oh, that was actually pretty good. All right, 1/4 cup vinegar. And then our next step is we're going to add some baking soda. This is going to go inside a balloon. I'm not going to dump it quite yet because I want to make sure I fill out both bottles. I'm going to use the funnel since I don't have anyone helping me out today. So I have the funnel right here. And I'm actually going to do 3 tablespoons of baking soda through our funnel into our balloon. So let's go ahead and count them. We're gonna make sure they're as flat as can be. There's 1. We're gonna shake it. I might not need my pencil. 1, 2. Not bad. I'm not gonna need my pencil after all. This is pretty good baking soda. It's pretty fresh. 3. Oh, is it all gonna fit? There we go. All right, 3 tablespoons of baking soda in my balloon. All right, so then what I'm gonna do is I'm gonna stretch the end of the balloon over the bottle. And like I said, I'm not gonna quite dump it just yet because, ooh, that is a heavy balloon of baking soda. Because I wanna fill up my second one and do them at the same time for you guys, a little bit differently. So this one I measured exactly 1/4 cup of vinegar and 3 tablespoons of baking soda. So this other bottle, it's a little bigger, not too much bigger. I want to go more. So maybe I know that 1/4 cup of vinegar in this bottle is going to cover that first line. I'm going to do a 1/2 cup. I'm going to do the 1/4 cup twice and do a 1/2 cup. Let's fill it up. And I'm just going to go ahead and pour. I'm going to guesstimate, estimate. Vinegar. Oh, that is stinky. There it is. So I'm wondering, this one I did exact measurements. This one I'm adding a little bit more. I'm also wondering if because I'm adding more, will I have a bigger, crazier chemical reaction here? Same thing, I'm going to use my glove this time. If you don't have a balloon at home, you could use a glove. These are my first aid kit. I'm going to fill it up. Should we add more? Should we double this too? So we did 3 in that bottle. Let's do 6. Is that too much? I don't know. We're going to test it out. We're going to do some experiments. 1, 2, 3. We're halfway there. It is a bigger glove, so it might hold more than the balloon. 4, 5, so let's talk about that. All right, there we go. All the baking soda's in there. Put that back, and we're going to stretch it over the bottle. So let's talk about what's about to happen here. We have liquid vinegar in each bottle, liquid. The molecules flow freely, fill the space that it's in right here. And then we have a solid. We saw that baking soda. It's a powder. It's like small little granules. They still fill that shape. They're stuck together. They don't move very far unless we do something with them. And what we're going to do is we're going to combine that solid baking soda with that liquid vinegar, and we're going to see what happens. And it might happen pretty fast, so get ready for your observations. We're going to take note of what we're seeing, what we're hearing, and what's going on. I'm still smelling the vinegar. It's a little stinky. All right, so once you have your setup done, we're going to go ahead and we're going to flip the balloons and the gloves right side up to make sure that all of the baking soda goes down into that vinegar. Are you guys ready? Let's count. Here we go. 1, 2, 3. Woo! Look at the glove! There was a hole in my glove. I saw lots of fizz. I hear fizz. And we got a gas filling up of the balloon and the glove. That was a lot of fun. There was a hole in my glove. That's why we heard that loud noise. Hi! Sometimes in experiments, unexpected things happen and you roll. I definitely think this one had a larger chemical reaction because we had additional materials. We added so much more. But they both filled up pretty fast. We saw the fizzing. We heard the fizzing. We saw the bubbles. We saw that chemical reaction, heard that chemical reaction happen, and we saw the product. My poor hole in my glove. Hi. The gas that was produced, the carbon dioxide, filled up our balloon and our glove. Looks like Miss Barb has a mess to clean up before we do our next experiment. I hope you guys had fun and you stay tuned for more experiments at home with Port Discovery. Bye guys! Alright everybody, we've got some more bottle science experiments for you today. We are going to take 2 more bottles, some more ingredients, mix them together, and see what kind of chemical reactions are in store for us. So as you can see, I have gloves on because I brought a special ingredient from work that's a little stronger, and I want to make sure it doesn't irritate my skin. The hydrogen peroxide also might be a wise idea just to have gloves on too. Goggles and glasses advised as well to protect your eyes because it can be an irritant. Hydrogen peroxide usually can be found in the drugstore, Walgreens, CVS, etc. 3%, pretty standard. In this container, I have 12% from work. We also have our dish soap, Palmolive, Dawn, Joy, whatever you have around the house. We have active dry yeast. This is a whole container. You can also get it in the small packets. We have some food coloring to add a little color into our lives. And then we have some measuring tools like our other experiments. We have 1 tablespoon, which will be for the yeast, and we have some mixing cups right here. So the first step that we're going to do is set up your experiment, get your gloves on, get your goggles on. I also did put down a tray. This one naturally tends to get a little bit messy, but it is so worth it. So you can do it on a tray in your kitchen. You can do it out on your patio or driveway. Just know that it's a hot mess express, but it's a ton of fun. So like I said, the first step you're going to do is you're going to put about 4 ounces, so about 120 milliliters of hydrogen peroxide. So right here on this side, I also have milliliters, so 50, 125, so just a little bit below. I measured out my 12%, so we're going to go ahead and we're going to measure out, oh look, Miss Barb, she's already got it covered, 120 milliliters of 3% for this bottle. I have my funnel again to help with spilling. These bottles are a little taller, these are a little narrower, so the funnel is good. This experiment is good with narrow bottles just for the effect that we're looking for. Alright, how many of you have heard of elephant toothpaste? This is what we're going for, toothpaste effect. Alright, so we've got 120 milliliters of our 12% hydrogen peroxide. We've got 120 milliliters of our 3% hydrogen peroxide. I'm going to add a little bit of soap swirled in here, Just a little bit, not too much. All right, we're gonna swirl that around. Okay, and then the next thing I'm gonna do is we are going to add a little bit of food coloring. Now, surprise, surprise, this is a little soap bottle, this is a little juice drink bottle. I think it's flavored water, but if you have other little bottles with narrow opening, this is a little travel bottle. So I'm gonna do a little side experiment right here. I know this is not, it's about 4 ounces, 3 ounces by itself. So I'm gonna do half of that. I'm gonna do a little eyeball with my 3% real quick. Miss Barb likes to experiment in all sorts of different ways. So let's go ahead, let's fill it half. Maybe we should do a quarter, but we're gonna do half. All right, so a little squirt of dish soap. And then when we do our next ingredient, we're gonna have to remember that this one is a halvesies. All right, 120 milliliters, 120 milliliters, and a halvesies. So here we go, 60 milliliters. Next step is we're gonna add a little bit of food coloring. So you can do it a couple different ways. It just depends on what your favorite color is, what your favorite color combination is, how much color you want in your chemical reaction world. I'm gonna do this one. Try to get it on the edges if you can. If you can't, that's okay. Maybe this one will just be red. Or purple. Maybe it'll be purple if we mix blue in there. It kind of ran down the edges. You can see a little bit. All right, let's do blue. Love blue. You can see I'm tilting the bottle so it runs down the edges. Run down the edges. What color should we do? Blue and yellow. I don't know what kind of loveliness that's gonna make, but we'll see what happens. Okay, so we've got our color in there. We've got our hydrogen peroxide in there. And now we need our final ingredient, which is the yeast, which is gonna cause our chemical reactions. Okay. So we need 1 tablespoon, Miss Barb didn't open that, of yeast. This is fresh, brand new yeast. Yes, Miss Barb loves to cook. I have 1, 2, 3. That was dry, yes. Okay, so it's 1 tablespoon of dry yeast. 1 for you. 1 for you. And remember, this one's a halvesies, so let me go get my little special teaspoon. Actually, let's do a halvesies. I'm winging it today. Let's do a little bit more. All right, that's our halvesies. Halvesies for our little baby jar right here. Okay, got our yeast. Now, we're doing 4 tablespoons to 1 dry yeast tablespoon. Warm water, the hotter the better, to activate the yeast. All right, and then remember this is a halvesies, so instead of 4, we're gonna do 2. All right, here we go. Woo, too much, too much. 1, 2, 3, 4. Mix it up. Activate, 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 activate. All right, how many? Ready? 1, 2, 3, 4. Activate, 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 activate. And how many for this one? We're doing halvesies, right? So 1. Ooh, Miss Barb. 1, 2. Activate, 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 activate. All right, so this is where we can decide to use our funnel, or we're just gonna wing it. We're gonna random see what kind of spillage happens. Okay, here we go. Water off. Get into positions. chemical reaction right here. Hydrogen peroxide, food coloring, dish soap, and yeast. Maybe we should do the funnel. Should we do the baby first? Oh, wrong one! All right, there we go. Fizzing, fizzing. Whoa, that one was awesome. That's the 12%. Bottle overboard. Ooh, and some green fizz. Bottle overboard. Watch out. Mess in Miss Barb's kitchen. It's still going. What do you think about that? That's the toothpaste effect. So we've got some fuzzy volcanoes over here. We've got a really toothpaste looking swirl going on right here. And when I picked up that bottle, what's crazy about this experiment is, so we're seeing a couple different things right here. The yeast caused the oxygen molecules in the hydrogen peroxide to be released. And the oxygen is being released causes the foam. And the chemical reaction, the hydrogen, is being broken down into water and oxygen. So this reaction, when I picked up the bottle when it fell over, is also called exothermic. Exo meaning outside. Heat is being released outward, heat. So this bottle is actually pretty warm to the touch. Look how colorful that is. Colorful explosion. Elephant toothpaste, chemical reactions in a bottle. I like the color choices though. That actually turned out well, including the purple. Anyway, Barb has another mess to clean up before we head on to our final experiment. Stay tuned. Experiment 3 coming your way. Hello everybody, we are back in action for our final experiment, bottle science with Port Discovery at home. And we have our 2 bottles for our last experiment. We're going to fill them up with some water. We have some vegetable oil, food coloring, and alka seltzers. Do you know where this is going? Yes, we're going lava lamps. So what we're going to do is we're going to fill your bottles. You can fill them about 1/4 to about 1/2 up with water. We're going to do that for both of our bottles. I'm going to go a little bit less than half. It's like 1/2 to 1/4 to 1/2 filled with water. And then we're going to add our oil on top. Now, we're going to talk about density today. Density is how closely packed molecules are and then where they sit in comparison to another. So we see the water is sitting at the bottom of the bottle. And when I put the oil on top, do you think it's going to sink down to the bottom of the water? It's going to be more dense than the water? Or do you think it's going to sit on top? It's going to be less dense than the water. Let's go ahead and check it out. More dense or less dense? Let's see where the oil falls. We're going to fill the oil up about leaving almost to the top. Leave about 1 inch. Look at all those bubbles. So pretty. All right, so I'm going to leave it about almost up to the top. Whoa, too much. Boop. All right, so we're looking here. This is telling us that the water is more dense. It is still on the bottom. The oil is settling on top. We have a lot of bubble layer right here, which will probably break and settle and just end up with the oil, just one big layer sitting on top. That means that the water molecules are much more closely packed together than the oil ones. They're pretty closely packed, but not like that water. So we're going to go ahead and fill up our other bottle almost to the top. Leave about 1 inch. So we have room for the rest of our chemical reaction. There we go. Need to get some more oil. Love this experiment. All right, so we've got our water, we've got our oil, got some bubbles going on right here. Now we're gonna add our liquid food coloring. So Love Green, Hello Spring. This is also a liquid, right? Liquid food coloring. So if I squeeze this into the oil and water, what do you think is gonna happen? Is it gonna mix in with the oil? Is it gonna mix in with the water? Is it going to sit in between? Is it going to be less dense than the water, so sit above, but more dense than the oil and sit right in the middle? Is it going to be more dense than the water and sit at the very bottom? Or is it going to be less dense than the water and less dense than the oil and sit on top? Let's go ahead and check it out. So let's do green over here. Ready? 1. You do like 3 or 4 drops. You see the beads falling down. Looks like they're resting on that bubble bed that's hasn't settled quite yet. We'll see what happens. Oh, it's kind of, oh. Can I flick it? We'll see what happens. I think there is going to be the same density as the water. I think it's going to mix into the water eventually. What do you think? Blue? Blue might be pretty. Blue and green. 1, 2, 3, 4. Oh, there it goes through the oil. It's more dense than the oil, resting on the bed of bubbles. We'll see what happens. Like I said, I think it's going to eventually mix in with the water. It's the same density. Let me tell you all about that. It's going to mix with that water. All right, so now we have our color. We've got all the liquids mixed in. The last step is we're going to add in our alka seltzers. So here we go. Gonna break them in half. You can break them in quarters if you like. Oh, mine already did. Mine broke into thirds. And we are going to see what happens when our alka seltzer touches the water. Let's see what kind of reaction we get. The oil and the water. Here we go. Ooh, we got some big bubbles. We've got some small bubbles. Oh, there we go. It popped the food coloring. It's turning green. Oh, there goes our blue. Oh, that's pretty. That's really nice. So what we've got, do you hear it? We've got fizzing, we've got bubbles, it's stirring around, it looks so lava lampy. So what's going on here is that when the alka seltzer hits the water, it creates a chemical reaction that results in the air bubbles that you're seeing, creating the movement in the lava lamp. So we're not gonna put the lid on right now because you can see it's bubbling up towards the top. And we don't want the top to pop up or for this bottle to explode. That would be way too much. But what I do wanna do, what I would like to try, is I want to put some light on this. That's why I have my camping lights right here. So let's go ahead and put some light on these lava lamps. You can use a flashlight, a little disc light. You can use camping lights. And once the bubbles start to fade, if you want, you can add more alka seltzer on there for as long as you feel like you want to watch it. The more you break the alka seltzer into smaller pieces, the more surface areas the water and oil are going to touch. So it's going to dissolve a lot faster. There's more surface area that's getting touched at the same time, versus if you have a larger piece, it's going to dissolve a little bit slower and last a little bit longer. Look at it! So pretty! You guys can keep playing with this experiment in different ways with different bottles. If you don't have vegetable oil, you can use baby oil. If you don't have alka seltzer with you, you can do 2 parts baking soda, 1 part citric acid. And you can also try swapping out tap water for tonic water. So there's a lot of different ways that you can play with this experiment. You can use the different colors. You can do a couple different ones next to each other. Try different color combination. Look at that big bubble right there. That's awesome. I hope you guys enjoyed all of our different experiments today. Bottle Science. We have a matching blog on our Facebook page to be shared and posted so you guys can continue to try these experiments at home. Don't forget to share your results, share your photos, share your different trials that you've done, different tests that you've done with different ingredients, and play on, science on, and I hope you guys have a great day.